Hello everyone, welcome back to another video. Today we'll be talking about the formal definition of a limit. The process of it is pretty straightforward actually. It's just a little weird to get used to at first, the notation. The theory is also a little weird, but you don't really have to use it exclusively to understand the problem. So what's going on is, let's say we have really just any sort of graph. I'm going to first go over the theory, then we'll go over everything else after. So the idea is that we're going to have a few things to deal with. We're going to have this L, which is defined as just a limit value, which from the previous of the limit, we also then have the C value, which is kind of what the X value approaches. We have what's called the epsilon, and we have a sigma. And these will be used for this one only, for this definition. I know they kind of are weirdly thrown in, but they're not too bad to work with in the problem. So for the graph's sake, let's just say we had some value C. And then we had another value over here, and it's going to be C minus your sigma. And then on the other side we have the C plus the sigma. And then we're going to have something really similar going on the y-axis. We're going to have an L, so the limit. And then we're also going to have the limit plus an epsilon. So just basically the same thing that's going on both sides here. And we're going to have a limit, and we're going to be minusing the epsilon. Okay? And let's just say we had just any line kind of coming out from it. And because we want to understand what the limit value means, we're going to say that there's some point where the L and the C value meet, and this is going to be between where the C and the sigma and then the L and the epsilon meet as well. So let's just say those are these points as well. So as you can see, the L and the C, they meet at a point between the epsilon and the sigma. And even though they're using these weird Greek letters here, they're really just trying to say the sigma is representing some sort of x point, and the epsilon is representing some sort of y point. And if you notice, one's adding and one's subtracting. They're trying to say that the limit is in between one of those values. And if we can find what the epsilon and the sigma are in relation to the limit value, we can prove that the limit is real, or we can prove that it exists for that definition. So if this was kind of confusing to understand exclusively, don't worry. It's one of the more out there theory topics. But the only thing you really have to understand that's important to is these two kind of formulas for when you're working with a problem. So they're always going to give you two things. They're going to give you the absolute value of x minus the C value, and that's going to be less than the sigma. And then similarly, we're going to have the absolute value of f of x, and that's going to be minus your L value, and then that's going to be less than your epsilon value. So if you notice, we're using the same notation as we saw in that graph. We're just going to prove this in a written format. So if you look at this, this looks a little strange. You ask yourself, what in the world am I supposed to do with this? Well, it's actually not as bad as you may think. So let's just say we had any sort of function. Let's say we had f of x is some function, and they usually won't give you functions that are too insane because they need you to prove it with this. So let's just say we had a limit, and your problem is going to be weird sometimes because it's actually going to give you the limit and everything and the answer. So they're going to solve the limit. So let's say we had the limit of 2x minus 1 as, let's just say, x approaches, let's just say 4. And this whole thing, they're already going to tell you it equals to 7. So the whole limit already equals 7. So what do we do with this? Well, we basically just have to plug in all the stuff they give you from the limit and prove that the sigma is equal to the epsilon, essentially. And when we prove the sigma is equal to the epsilon, well, then we're proving that if you recall that graph, so remember that we had the things in between. So if we prove that the epsilon here and the sigma are equal to one another, then we're proving that the c value here and the limit are also going to meet as well. So that's kind of the whole gist of why we're doing this. But to first actually solve it, we just have to recognize what each value is. So whenever you have your x value, just like normal, your c value, just like we've already been taught, is this whatever the x is approaching. It's still the c value. Your f of x is going to be the function, just like normal, and your answer to the limit is still going to be your L, your limit value. So nothing is really changing per se. All that's changing is using these formulas. So let's start using that formula then, okay? So let's plug in what we can for the first one. Okay, well, let's think about this logically. Do we know what the x value is? We don't know what the x value is, and then they didn't give that to us in the limit. Okay, let's move on then. Do we know what the c value is? We do. The c value is 4, so we can go ahead and plug in the 4 as your c, no problem. Do we know what the sigma is? We don't know what sigma is, and you'll never know what sigma is usually, unless they give it to you purposefully so you can actually find what epsilon is. But usually, you won't know what either one of them are. Okay, let's move on then. So usually you won't be able to do too much with this first one. It's this one that you're going to work with quite a bit. So this one has f of x first. So f of x, do we know f of x? We do know f of x. F of x is 2x minus 1. And do we know what the limit is? We do know what the limit is. The limit in this case is 7. So let's just plug in 7. And I recommend putting parentheses here. It doesn't matter in this case because it's just a positive 7. But if they gave you a negative, an easy mistake to make is to just put this as a negative 7 and forget that you have to carry over the negative sign. But in this case, it doesn't matter. So let's then do that, and we don't know the epsilon value. So we've plugged in everything we can. But what do we do now? Well, we're going to leave this one be, but we're going to rewrite it just because we want to try to not forget what we're trying to, our goal is. Because what you're going to find is this one is what we're trying to make this one be. So we're trying to manipulate this function to be this one so that our sigma and epsilon equal one another. So if we were to just first of all simplify, we'd get this as 2x. This is a negative 1. This would be a negative 7. So negative 1 minus 7 is minus 8. Okay, so we've done our simplification. Is there anything we can do to make 2x minus 8 absolute value to x minus 4? Well, it looks like we can't. We can take out a 2 and it should turn into it. And because this limit is defined, there is a way you can kind of manipulate this to turn this into this. Because the limit already works, you're just proving it for the definition. Okay, so let's try to take out a 2 and see what happens. So if we take out a 2, then we get that it's x minus 4 absolute value, and all of a sudden this looks pretty much the same. But we can't leave this be. We want this to be exactly the same. So we can't have a 2 on the outside. So let's then divide by 2 to get the absolute value statement the same as the sigma one. So we just have to divide by epsilon. I know it's weird, but kind of just treat epsilon like an x value. Then we'll get x minus 4 absolute value is less than your epsilon over 2. Now you've pretty much finished the problem. There's not too much to do. So as I said, the actual math usually isn't too bad in the problem. It's just getting used to all of these, what they mean, plugging them in. But once you plug them into their respective formulas you just memorize, it's actually not too bad to manipulate it. Okay, but let's now think about this another way. Teachers will differ on what they want you to do. Sometimes they'll want you to kind of create a lengthy explanation as to why they're equal. Most teachers won't have you do that though. They just want you to realize that this statement and this statement are the same, and that's how you're proving that the limit exists. So usually what they're going to have you do is you're first going to box your epsilon that you calculated. And then you're just going to make a statement equaling them, because since x minus 4 and the absolute value of x minus 4 are the same on both sides, you've proven that it exists. So all you really have to do now is say that, you can really say anything, but usually teachers like you saying thus. So thus, we would say that sigma, so we're just going to be putting whatever we got for the same value, equals to epsilon over 2. So as you can see, this would be what you're trying to get. You're just trying to make a statement that shows that these two things are equal, which then says that because of the definition of the limit, we already figured out that, of course, that means now that the limit and the c value are equal. Again, the theory is a little bit convoluted at times, so if it's just not clicking, that's okay. Just understand this is the process they usually expect from you. So if we go ahead and let's just say we had another limit that's kind of similar, so we're kind of practicing the same idea. So the limit, as let's just say it's x approaches 2 of, let's just say, 3x minus 10, and this is going to be equal to negative 4. So a little bit, it's still linear function. They're usually going to give you linear functions because you have to manipulate it like we did in that section. But we're going to give a little bit more difficult one just so we have good practice on it. So you can pause it now if you want to do it on your own, or you can follow along. So again, I always like writing our formulas just so that we don't get lost, because this is the type of problem where it's easy to get lost. We have the x minus c is less than the sigma, and of course the f of x minus the L is less than the epsilon. So the same process applies. What should we do? Well, first, let's go ahead and do everything we know. So we know that the c value is going to be 2, and we know that our f of x value then is going to be 3x minus 10, and parentheses, we're going to just subtract whatever our limit value is. Our limit value is negative 4, and we're just going to have that less than epsilon. Okay, what to do now? Let's just rewrite our sigma 1 one more time. You are free to keep rewriting this over and over again. You don't have to though, if you don't want to. So 3x minus 10 is the same. We're just going to distribute the negative, which turns it into a positive 4, and then we're going to have that be epsilon. Now let's combine terms. So negative 10 plus 4 is negative 6. So let's put that right there. And we can end up doing something similar. So how can we make 3x minus 6 similar to x minus 2? Well, we can take out a 3. So let's do that then. Let's take out a 3. Let's make it x. And then, of course, 3 times 2 will give you 6. So it's minus 2 gives you an epsilon. And now it's the same. We just like before have to divide. And then, of course, we're going to get that it's going to be the absolute value of x minus 2 equals to the epsilon over the 3. And we can just go ahead and box this if you'd like. But the more important thing, since we've now equaled them, they now have the same c value. We can then say that the thus, or therefore, you don't have to use thus if you don't want, thus the sigma is equal to the epsilon over 3. And that's really all you'd have to do for these problems. So most of it is just proving something. You can think of it like you're proving the theory that already exists. So they're giving you the theory, they're giving you the means to check it, and you're just checking that it works, and it always will, and you'll always get that the sigma equals some epsilon value. Sometimes they'll give you what the epsilon is, but the process is the same. Instead of just having like a epsilon here, you would have some number, and you would just say that sigma equals to some number over 3. So just keep in mind that they could give you a number instead, but the process is still the same. Okay, I hope this helped with the definition of a limit. Thanks for watching.